Today we're going to talk about the division properties when we're looking at our powers. So when we have a power, again, looking at powers that have the same base, we want to subtract our exponents. So this is a new property adding on to the multiplication properties that we discussed yesterday. So let's look at why this is. So let's expand an example. If I have x to the fifth over x squared, that means I have 5 factors of x in the numerator and 2 factors of x in the denominator. And we know that when we have a fraction, if I have a number over the same number, that I can just cancel that out. It's just going to reduce. And if I cancel this x with that x, this x with that x, that's going to leave me with 3 x's. And those 3 x's are in the numerator, and I no longer need that denominator. I've eliminated it. If it was the other way around, if I had x squared in the numerator and x to the fifth in the denominator, let's look at what that would look like. That would still cancel these x's out and leave me with 3 factors of x. But in that case, the 3 factors of x live in the denominator. So I still need to write that numerator to be 1 over x cubed. What I like to do to avoid having, we haven't talked yet about negative exponents, and there are properties involving negative exponents. But to avoid negative exponents, if we always subtract the larger exponent, subtract the smaller exponent, and make sure that we understand that we need to keep the variable where the larger exponent was. This allows us to avoid running into negatives in this case, meaning here, my larger exponent was in the numerator, and I subtracted 5, subtract 2, gave me 3 in the numerator. Or on my second equation, my larger exponent is in the denominator, and I still do 5, subtract 2, but those 3 factors of x live in the denominator because that's where my larger exponent was. So let's look at a couple examples here. And first, let's consider if we had more than one variable. So if I had x cubed y to the 4th over x y to the 7th. So when I do this, I'm kind of looking at my x's and my y's separately. So I'm looking at my x's have the same base, my y's have the same base. That's where I'm focusing on to apply this property. So for my x's, I have 3 in the numerator and 1 in the denominator. I have more factors of x in the numerator than I do in the denominator, which means I know that x is going to live in the numerator in the end because I have more factors here than I do here. In subtracting, 3 subtract 1 tells me that I will have 2 factors of x left in the numerator. For my y's, I have more factors of y in the denominator than I do in the numerator. I have 7 in the denominator and 4 in the numerator. So that tells me that I'm going to have factors of y left in the denominator, and 7 subtract 4 tells me I have 3 factors of y left in that denominator. I also want to talk about our coefficients again. So let's say I have 2x to the 6th over 6x to the 10th. Just like when we're looking at multiplication properties, these integers are still going to operate the way integers always have. So all we're going to do here is reduce that fraction, or say that 2/6 reduces to 1/3. And then for my exponents, we'll apply our property. And I have more x's in the denominator than I do the numerator. So I know x is going to land in the denominator. And I have 4. When I subtract 10, subtract 6, 4 remaining factors of x in the denominator. Another thing we want to look at, I'm not going to do kind of expanding this out with a different property, is if I have a fraction inside my parentheses here. So let's say I have x cubed y over x to the 5th y squared squared. Everything in here is getting squared. So there's actually 2 ways I can go about this. first I can go through, and so everything, numerator, denominator, I could go through and square everything, which if we go back to our last set of notes, if I'm bringing a power in, then I'm multiplying those exponents, which would make this x to the 6th, y to the 2nd, x to the 10th, y to the 4th. So squaring all of those terms brings me here. Now it looks like this, and I'm going to subtract. 10 subtract 6 gives me 4 factors of x, and it would be in the denominator. And 4 subtract 2 gives me 2 factors of y, also in the denominator, and so I need a 1 in my numerator there. Okay, so that's one way I could approach this problem, is square everything, which means we're going to multiply exponents, then deal with the division property. I could have also, let me rewrite the problem. I could have also done the division property first. So I could have said, okay, well, within here, I'm going to be left with 2 x's in the denominator and to subtract 1 y in the denominator, still leaving it in parentheses. And then after I do the division property, then square everything. And so 1 squared is 1, x squared squared, multiplying is x to the 4th, y to the 1st squared is y squared. So same answer. Here I chose to do the power property followed by the division property. Whereas here I did the division property followed by the power property. Gets you to the same place overall. And so what I always tell students is do something, right? Do a property and then look to see, can I continue to simplify until you get to a space where you can't apply any other additional exponent properties. So let's look at a few simpler examples and then we'll kind of go beyond that as well. So first example here, instead of having to evaluate each of these and get these larger numbers, I can just say, well, I have 5 here, 4 there, taking that away. That just means I have 1 factor of 4 in the numerator, or just have 4 the first, 4. On B, I may want to use P-man in that numerator where they're being multiplied. I know that I can add exponents, which gives me 6 to the 8th. And this is easier than having to evaluate these large numbers and actually multiply it out. If I add exponents, and then I say, okay, division property, I can subtract exponents, brings me to 6 cubed, which is, we're not even going to evaluate it and worry about that, but it gives me something a little simpler to work with than having to work with the numbers that they were first presented. On C, this x squared is in the numerator, so we want to think about it like this, which really means we have 1x squared in our numerator and 1 times x to the 4th in the denominator. Division property tells us we can subtract. I have more factors of x in the denominator. So subtracting 4, subtract 2 gives me x squared. Same idea on D. I have more factors of x in this case in the numerator. 18 subtract 15 gives me 3, and it's in the numerator, so I don't need that denominator anymore. I have more in the numerator. It gives me -5 to the 2nd. Now in this case, just kind of as a reminder, because it's negative, negative times a negative, if I were to evaluate that, will give me a positive 25, which is different, by the way. -5 squared is positive 25. -5, not in parentheses squared, is actually -25. If it's written like this, then I'm also squaring the negative. If it's written like this, then it's like a -1 times 5 squared. Okay, so those can be tricky in terms of when you have those integers there, and just be careful. On F, using P-man, I know that if I multiply those, I can add them together, which gives me 3 to the 12th. And then subtracting exponents leaves me with 2 factors of 3, in the numerator, and 2 factors of 3 would be 9. Looking at the other property where I could have my quotient, a fraction being raised to a power, and then possibly need to use my quotient property from there. So we just want to be careful with our integers here and kind of look at it carefully before we look at more complicated examples. So bringing in a power of 2 here, 2 squared, remember this is now just integers, so it just becomes 4/9, and I'm done. So same idea here. I need to make sure I treat this -3 like I would any normal order of operation, any type of problem where I'm just evaluating. -3 cubed is -27. Y cubed is just going to be y cubed. Bringing in a 2 here, 7 squared is 49, 4 squared is 16. Bringing in an exponent of 2 here, goes to both the numerator and the denominator. When I get to these last two, I have powers inside. So when I bring in this power of 2, it's a power to a power. Which remember, using P-man, when I have a power to a power, we multiply our exponents. So this is going to become 2 to the 8th over x to the 10th, and I'm just going to leave the 2 to the 8th there. Bringing in this power, same idea. These powers, when you choose our property and multiply, gives me x to the 12th over y to the 21st. Okay. Now, I'm going to do maybe 2 of these, and I'll let you look at the rest of them. So this is looking at the division property when we have coefficients. So we always have to remember that we treat our coefficients different than we treat our powers. So for example, if I look at this second one. This second one, I'm going to look at the 15/50ths separate from the r's. I'm going to look at the r's separate from the s's. So first, looking at the 15/50ths, here I'm just going to reduce. These are just numbers, just like 15/50ths has always been. So reducing 15/50ths reduces to 3/10. Then what happens here for my r's is I have r to the first over r to the first, or these r's are just going to cancel out in that problem. And for the s's, I have 2 here, 1 here. So I have more s in the numerator than I do in the denominator. And 2 subtract 1 leaves me with 1 s. So just cleaning that up a bit. Gives me 3s over 10. Let's look at the one below that. Looking at just the integers first, and again, reducing that. -4/8 reduces to -1/2. Okay, I'm not using properties of exponents there. For my x's, I have more x's in the numerator than I do the denominator. And 7 subtract 3 brings me to 4. And for my y's, I also have more in the numerator than the denominator. And 3 subtract 1 gives me 2. And I could rewrite this without that -1. I could write -x to the 4th y squared over 2. Okay. So now I want you to pause the video and try the remaining 4 questions here, and then restart the video and see how you did. Okay, so looking at these remaining problems, first one, 12/15 reduces to 4/5. I have 3, take away 1, leaves me with 2 factors of m. 3/12 reduces to 1/4. 5, take away 3, leaves me with 2 factors of x. 28/7 just reduces to 4. I have an x here that can't be combined with anything, so it's just still there. And 4 subtract 3 leaves me with y to the first. We already did this one. 28/24 reduces to 5/6. X squared over x gives me 1 factor of x. My y's will cancel. Z to the 4th over z to the first gives me 3 factors of z in the numerator. Okay. So now I do want you to practice this a little bit further today before you won't have homework with division properties until next week. So work through this page, and I'll post the answer key to this page in the assignment with the video link.